Hello science fans! Are you ready for an electrifying adventure? Today, we're diving into one of the most fundamental forces in the universe, a force that shapes our modern world in countless ways. Get ready to explore the amazing world of science. Today, let's uncover the invisible force that powers our world, the very essence of modern life, the energy that keeps our cities bright and our homes comfortable, electricity. From the smallest spark to the most powerful lightning bolt, electricity is all around us, a constant companion in our daily lives. Imagine tiny particles called electrons, the fundamental building blocks of electricity. These subatomic particles are the key to understanding how electricity works. They're everywhere. These tiny particles are present in virtually every object around you. In your desk, the very wood and metal are teeming with electrons waiting to be put to work. Your hair. Ever notice how your hair stands on end sometimes? That's electricity at play. Even your pet hamster. Yes, even your furry friend relies on the flow of electrons to keep their tiny heart beating. When electrons get a push, they move. When these tiny particles are energized, they begin to flow in a coordinated manner, creating electricity, a flow of energy, a dynamic movement of charged particles that we can harness and use. Like a river of invisible particles, constantly moving and carrying energy from one place to another. Think of it like water flowing through a hose. The water represents the electrons, and the hose is like a wire. Electrons flow through certain materials in a similar way, especially those materials that are good conductors of electricity like copper. This flow is called an electric current, the lifeblood of our technological world. Electric current carries energy, transporting power from power plants to our homes and businesses, lighting up rooms, transforming darkness into light with the flick of a switch, powering gadgets, bringing our smartphones, tablets, and computers to life, and even helping your heartbeat. Electricity plays a vital role in medical technology, monitoring and even regulating our vital functions. Electricity is a fundamental force of nature, just like gravity, a force that governs the interactions of matter and energy in the universe. And we've learned to harness it to transform our lives. We've built complex systems to generate, transmit, and utilize electricity, shaping the world we live in. Without electricity, there'd be a very different world, a world without many of the conveniences we take for granted. No lights. Imagine a world plunged into darkness after sunset, relying only on candles and lanterns. No refrigerators, food would spoil quickly, and our diets would be severely limited. No computers, the digital age would never have happened, and information would be much harder to access, and no phones. Communication would be drastically different, relying on slower and less efficient methods. Understanding electricity helps us unlock the secrets of the universe and develop new technologies. Behind everything from flashlights to rockets, from the simplest devices to the most complex machines, electricity is the driving force. So next time you flip a switch and the lights come on, take a moment to appreciate the power of electricity. Remember, you're commanding an army of electrons to do your bidding. You're harnessing the power of nature to make your life easier and more convenient. Learning about electricity isn't just for scientists, it's for everyone who wants to understand the world. It's about understanding the fundamental principles that govern our universe. Appreciate the technology around you and get curious about how it all works. Ask questions, explore, and discover the wonders of electricity. Science is cool. Keep exploring, keep learning, and keep discovering the amazing world around you. We know electrons love to move. They're constantly zipping around, full of energy and ready to go. But even with all that energy, they can't just go anywhere they please. They need a specific pathway, a designated route to follow, to get where they need to be. And that's where the concept of a circuit comes in. Electrons need a path, a circuit, to follow. Think of it as a superhighway designed specifically for these tiny particles. A circuit, at its most basic, is a complete loop. It's a continuous, unbroken pathway that allows electrons to travel from one point to another and back again, creating a flow of electricity. A circuit is what lets electricity flow smoothly and efficiently from a power source, like a battery or a wall outlet, through various devices such as a light bulb or a motor, and then safely back to the source, completing the cycle. Think of it like a toy train track, a closed loop where the train can travel continuously. If the track is complete, forming a continuous circle, the train, which represents our electrons, can keep going around and around, happily moving along its path. But if there's a break in the track, a missing piece or a derailment, everything stops. The train can't continue its journey. In this analogy, the electrons are the train, constantly moving and carrying energy, and the circuit is their track, providing the pathway for their movement. For electricity to work and power our devices, the path must be unbroken. A full circle, a complete and continuous loop. Any interruption will halt the flow. That's why batteries, the power sources for many of our devices, have two ends, a positive and a negative terminal. Electrons flow out one side, typically the negative terminal, travel through the circuit, powering the device along the way, and then return to the other side, the positive terminal, completing the loop. Every electronic device we use, from the simplest to the most complex, from simple holiday lights that twinkle and brighten our homes during the festive season, to complex TVs that bring us entertainment and information from around the world, relies on this fundamental principle of a complete and unbroken circuit. Circuits are more than just simple wires connecting components. They're carefully designed highways for electrons, meticulously planned to ensure efficient and reliable flow. Without a complete circuit, electricity is just waiting, like a car without a road, ready to go but unable to move until a pathway is provided. So, always remember this crucial rule: no circuit, no flow. If the path isn't complete, electricity simply won't work. Every device you use, from your smartphone to your refrigerator, is built around this simple yet powerful rule of electrical circuits. The circuit, therefore, is the Electron superhighway, the essential pathway that makes modern electronics possible. That's the secret behind all our amazing gadgets and devices that we rely on every single day. Understanding circuits is key to understanding how electronics work. Every circuit has three main parts: the power source, the path, and the load. The power source, like a battery or wall outlet, gives electrons their push. The path is usually made of metal wires, which are great conductors, letting electrons travel easily. The load is the device that uses the electricity, like a light bulb, motor, or buzzer. The battery pushes electrons, the wires guide them, and the load puts them to work. All three must be connected in a loop for the circuit to function. If any part is missing, nothing happens. In a flashlight, the battery, wires, and bulb all work together to create light. In a toy car, the load is the motor that makes it move. The load is the reason we build circuits. It's where the magic happens. Power, path, and purpose, the foundation of every electric device. Connect them right, and you've got a working circuit. That's the heart of every electronic invention. For electricity to flow, the circuit must be closed, a complete loop. In a closed circuit, electrons move freely, powering devices like bulbs and motors. It's like a train on a full track, looping endlessly. This continuous movement is called current. When you see a light on, you're seeing a closed circuit in action. But if there's a break, a wire is loose or a bulb is out, the circuit is open. In an open circuit, electrons can't complete their journey, so nothing works. It's like a drawbridge raised. Cars, electrons can't cross. If your flashlight stops working, check for an open circuit. Maybe a loose battery or bulb. Closed means go, open means stop. Understanding this lets us control electricity. Every switch, button, or connection is about opening or closing the path. Mastering open and closed circuits is key to using electricity safely and effectively. It's the basic rule behind every electronic device. Remember, closed circuit, energy flows; open circuit, everything stops. We don't want lights on all the time, so how do we control circuits? With a switch. A switch lets you open or close a circuit whenever you want. Inside, it's just two pieces of metal that touch, closed, or don't, open. Flip the switch on, the metals connect, and electrons flow. The light turns on. Flip it off, the metals separate, and the flow stops. Every time you use a light switch, remote, or button, you're controlling a circuit. Switches give us safe, easy control over electricity. It's a simple device with a powerful purpose. You're the boss of your electron army. In the world of electronics, we often need to power multiple devices simultaneously. Think about your home, your office, or even a simple gadget. Each of these relies on electricity to function, but how do we ensure that each device receives the power it needs without affecting the others? Want to power more than one thing? There are two main ways to connect electrical components to a power source, each with its own unique characteristics and applications. These two fundamental configurations are known as series and parallel circuits. Understanding the difference between them is crucial for anyone working with electronics, from hobbyists to professional engineers. In a series circuit, devices are connected one after another in a single loop, forming a continuous path for the electricity to flow. Imagine a chain where each link represents a component. Like a single-lane road with several toll booths. Each car must pass through each toll booth in sequence. The electricity flows through each device in turn, meaning the same current passes through every component in the circuit. Add more bulbs in a series circuit, and they all get dimmer because the voltage is divided among them. Each additional bulb reduces the voltage available to the others. If one burns out, the whole circuit stops working because the path is broken. The circuit is incomplete. That's how old holiday lights worked, creating a frustrating experience when one faulty bulb ruined the entire string. One goes out, all go out. This is a major drawback of series circuits. In a parallel circuit, each device gets its own branch, providing multiple paths for the electricity to flow, like a highway splitting into lanes, allowing multiple cars to travel independently. Each bulb gets full power because the voltage is the same across each branch, so they all shine bright. If one bulb burns out in a parallel circuit, the others stay on because the other branches remain intact and the circuit remains complete. This is how your house is wired, ensuring that each appliance and light fixture receives the necessary power independently. Turning off one light doesn't affect the others, allowing you to control each device individually. Parallel circuits are more reliable and efficient for most applications because they provide consistent power and prevent total circuit failure. Series circuits are simple to design and construct, making them suitable for certain specialized applications where simplicity is key. But parallel circuits are everywhere in modern life, powering our homes, offices, and countless electronic devices. Understanding the difference helps you design better circuits, optimize power distribution, and troubleshoot electrical problems effectively. More paths mean more control and reliability, ensuring that your electrical systems function smoothly and safely. That's why parallel circuits power our homes and gadgets, providing the foundation for modern electrical convenience and functionality. Electricity is powerful, and can be dangerous if not respected. Never play with wall outlets. The electricity there is much stronger than in batteries. Only adults should plug or unplug devices. Water and electricity don't mix. Never use electrical devices near water or with wet hands. Always use low-power batteries for experiments, and never short-circuit a battery. Even batteries can get hot if misused. Outdoors, stay away from power lines. Never fly kites or climb trees near them. If you see a downed power line, stay far away and tell an adult. Follow these rules to explore electricity safely. Be smart, be safe, and enjoy experimenting. Respect electricity, and it will power your world. Safety first, always. Now that you know circuits, you'll spot them everywhere. Your home is a web of parallel circuits, each room, each device, its own branch. Your morning routine, alarm clock, toaster, fridge, toothbrush, all circuits at work. Even buses and smartphones are packed with circuits controlling lights, motors, and screens. A smartphone is a city of tiny circuits, all working together. Every time you touch the screen or press a button, you're closing a circuit. Circuits power everything from traffic lights to hospital equipment. Understanding them means understanding the technology that shapes our world. Next time something lights up or moves, you'll know it's electrons on the move. Science is everywhere. Just follow the circuits. Did you know electricity in wires travels nearly at the speed of light, but electrons themselves move slowly? Some animals, like electric eels, are living circuits. They can deliver shocks up to 600 volts. Birds can sit on power lines safely because electricity needs a path to the ground to flow through them. If a bird touches two wires or a wire and the ground, it completes the circuit and gets shocked. The spark you see when unplugging a device is an electric arc, electricity jumping across a tiny air gap. It's a mini lightning bolt showing just how powerful electricity is. Stay curious, keep asking questions, and always consider the science.